So that long division stuff is rough. And as long as you're dividing by a linear factor, such as x minus a number, you can use a shortcut called synthetic division. So let's go divide polynomials using synthetic division. Now the disclaimer, it can only be used when the divisor is a binomial of the form x minus c, where c is a constant. Okay? So use synthetic division to divide 4x cubed minus 28x minus 7 by x minus 3. To go set it up, I gave you the template. Whatever your divisor is, x minus 3, set it equal to 0 and solve for x. That's the number that goes here in the little half box. Yes? Set the divisor equal to 0, solve for x. That's the divisor, that's the number that goes in the half box. You're going to put a list of numbers up here that correspond to the coefficients of your polynomial. Now be careful. You have to put them in decreasing orders, decreasing powers of x. Meaning, you see the 4 with the x cubed? Is there an x squared? No, so you have to put a 0 for a placeholder for the x squared. Is there an x? So put negative 28. Is there a constant? So negative 7. So that's how you've set everything up. The number in the half box comes from the divisor, set it equal to 0, solve for x. Then you put the coefficients from your big polynomial. You have to have zeros as placeholders if there's no x to that power. All right, here's the game. Bring it down. So you get 4. Now you're wanting to go back up to this position. How do you do that? You're going to do 4 times the half box number. 4 times 3 is 12. Now add, what's 0 plus 12? 12. How do you go back upstairs? You multiply by the half box. So what's 12 times 3? 36. And then you just add, what's negative 28 plus 36? 8. How do you go back up? You multiply by the half box. 8 times 3 is 24. And now add, what is negative 7 plus 24? 17? Okay, your original problem was a 4x cubed. Do you agree? So now we need to decrease the power of x by 1. And your answer is going to be 4x squared plus 12x plus 8 plus 17 over x minus 3. You have to decrease the degree by 1. Does everybody see how I got the answer? You're using these coefficients. This is the remainder. The remainder is off to the side over here. Shall we do this again? Yes, please.
We shall.
Okay, remember, the very first one gets dropped down. Then to go back up, you multiply. And then what are you doing when you're going down? You're adding. Drop it, multiply to go back up, add it to go down. Go do the next one. All right, first thing to notice, this is not written in decreasing powers of x. So I'm going to go do that first. And I have a 2x to the fourth, 7x cubed. Do I have an x squared? No, so I'm going to put a 0x squared, a negative 3x, and a plus 5. So my coefficients, I'm going to use these numbers on that line. I get 2, 7, 0, negative 3, and 5. What number is going to go in my half box? If x plus 1 equals 0, then x equals negative 1. Negative 1 goes in the half box. Drop down the 2. 2 times negative 1, negative 2. Add 7 plus negative 2. Do you get 5? Now do 5 times negative 1. Negative 5. Add 0 plus negative 5. Multiply negative 5 times negative 1 is 5. Add negative 3 plus 5, 2. Multiply 2 times negative 1, negative 2, and add 5 plus negative 2. That's my remainder, correct? So my answer, if I started with an x to the fourth power, this is going to be an x to the third power. Okay, so I'm going to write 2x cubed plus 5x squared minus 5x plus 2 plus 3 over what? X plus 1 over the divisor. Okay, the question was asked, why is this 0 right here? Why is that put there? You have to have, when you start with an x to the fourth, you have to have a placeholder for everything from x to the fourth down to your constants. So the x to the fourth, x cubed, x squared, x, and the constant. If your polynomial doesn't have the x squared, like this one didn't have an x squared, you have to put that 0 there. If you don't, your whole answer is going to be off and be wrong. Great question.
For the exponents at the bottom, you just subtract 1.
And so for your answer, when you get down here, you started with an x to the fourth. Your answer is going to start with an x cubed. And you just decrease all the way from there. X cubed, x squared, x, constant.
So this will be on the test, but you're going to have one that you would have to actually figure out.
So where are you going to use this? Right now, this section is just teaching you how. You're going to see where this is useful coming up. You're going to have to go find your zeros on a polynomial function that you're graphing. And remember, right now I told you how do you find them? You go put the polynomial into your calculator, and your calculator spits them out to you. But what if they're not nice? What if they're not integers? How are you going to find them? And you're going to do it by using this process. All right, go do another one. All right, here we go. I'm going to start leaving off some shortcuts. What's x minus 3 equals 0? X is 3, so 3 goes into the little half box. The coefficients up at the top should be 4, negative 25, negative 58, 232, 198, and negative 63. You agree? So if I drop the number down, I get 4. 4 times 3 is 12. Negative 25 plus 12 is negative 13. Negative 13 times 3 is negative 39. Negative 58 plus negative 39 is negative 97. Negative 97 times 3 is negative 291. 232 plus negative 291 is negative 59. Negative 59 times 3 is negative 177. 198 plus negative 177 is 21. 21 times 3 is 63. Negative 63 plus 63 is 0. The remainder is 0. How nice. This divides into this evenly. And what is the answer? Okay, this was an x to the 5th, so this is going to be an x to the 4th. So write them down. 4x to the 4th minus 13x cubed minus 97x squared minus 59x plus 21. There's no remainder.